Oceans in crisis, the silent collapse beneath the waves. Before we begin, take a second to like this video, share it with someone who loves mysteries and documentaries, and subscribe to Uncovering Facts, because today we're diving into a world that feels like another planet, and yet it's the reason our own planet still works. Most people look up into the night sky and say, space is the final frontier. But the greatest frontier on Earth is not above us. It's below us. It's the deep ocean. A place without sunlight. A place under crushing pressure. A place where creatures glow, where mountains erupt underwater, where ancient shipwrecks sleep in silence, and where the laws of survival look completely different from life on land. And now, a quiet emergency is spreading through this hidden world. Not with one loud explosion. Not with one single disaster that forces everyone to look. But with slow changes that stack on top of one another until the system begins to fail. This is the story of the ocean in crisis. And the scariest part is that most of the collapse is happening where human eyes rarely go. Number 1. The ocean is not just water. The ocean is Earth's life support system. It moves heat around the planet like a global conveyor belt. It drives weather and rainfall. It feeds billions of people. It holds ecosystems older than human civilization. It absorbs a huge portion of the extra heat from global warming, acting like a buffer that has protected life on land from even more extreme temperature shifts. But buffers have limits. And when the buffer gets overloaded, the bill comes due. We often talk about the planet like it's land with water around it. But Earth is an ocean planet. And when the ocean changes, everything changes. Number 2. The ocean is overheating in slow motion. Imagine holding a pot of water on the stove. Turn the heat up slightly. Nothing dramatic happens at first. But keep it going long enough, and the entire system transforms. This is what warming oceans are doing, quietly, gradually, relentlessly. Warming doesn't just raise the temperature. It changes how water layers mix. It affects oxygen. It changes currents. It alters species' comfort zones. It expands water, contributing to sea level rise. It fuels marine heatwaves, periods where ocean temperatures spike far above normal for days or weeks, stressing life like a fever that won't break. And unlike animals on land, many marine species cannot simply walk to shade or burrow into cooler ground or find shelter. Some can migrate. Others cannot. When the ocean warms, it reshuffles life. Number 3. The Great Migration nobody sees. One of the strangest effects of ocean warming is what scientists sometimes call marine range shifts. Fish and other marine animals are moving toward the poles and toward deeper waters, chasing cooler temperatures. That means species that once lived mostly in warm tropical bands are now appearing in new regions. It means fishing communities that relied on familiar species for generations can suddenly find their catch vanishing. It means predators arrive in places where prey has never faced them. It means ecosystems become unstable because relationships that evolve together, predator and prey, parasite and host, cleaner fish and client, get broken apart. And here's the strange twist. As life moves, it doesn't move evenly. Some species shift quickly. Others lag behind. So the ecosystem becomes mismatched, like a band where the drummer changes songs but the guitarist doesn't. The ocean becomes unfamiliar even to itself. Number 4. Coral reefs are turning into ghost cities. If the deep ocean is Earth's dark mystery, coral reefs are Earth's bright underwater cities. They're often compared to rainforests because of their biodiversity. They shelter fish, protect coastlines, and support tourism and fisheries. But reefs are also fragile. Corals live in partnership with tiny algae inside their tissues. The algae feed them energy. The corals give them shelter. It's a living alliance. When water becomes too warm, corals get stressed and expel the algae. That's coral bleaching. The reef turns pale, like a city losing power. Bleaching is not always instant death. If temperatures drop, corals can recover. But repeated heat stress is like repeated injury. After enough bleaching events, reefs struggle to rebuild. And when reefs collapse, the chain reaction spreads. Fish lose nurseries. Coastal protection weakens. Local economies suffer. And an ecosystem that took thousands of years to build can degrade in a handful of seasons. A reef does not die loudly. It fades. Number 5. The ocean is losing oxygen, slow suffocation. Now we descend into one of the most overlooked crises beneath the waves. The ocean is slowly losing oxygen, and life depends on oxygen just as much underwater as it does on land. Warmer water holds less oxygen than colder water. And as the ocean warms, it also becomes more stratified, meaning warm surface water and cold deeper water mix less effectively. Less mixing means less oxygen delivered downward. In some regions, oxygen drops low enough to create hypoxic zones, sometimes called dead zones, areas where fish and many other creatures cannot survive. Some dead zones are made much worse by human activity, especially nutrient pollution. When fertilizers and sewage wash into rivers and end up in coastal waters, they can trigger huge algae blooms. When the algae die, bacteria break them down, consuming oxygen. The result is a suffocating underwater zone where life either flees or dies. Here's what makes it frightening. The ocean can look calm at the surface. Blue sky. Waves. Boats. No sign of disaster. But underneath, oxygen can be so low that the sea becomes uninhabitable. A quiet suffocation. Number 6. Harmful algal blooms, when the ocean turns toxic. Not all algae blooms are harmless. Some produce toxins that can kill fish, poison shellfish, and cause health risks to humans. These are often called red tides, though they can also look green or brown depending on species. Warming waters and nutrient pollution can increase the frequency and intensity of some harmful blooms. When blooms expand, they can create fish kills, contaminate seafood, and even affect marine mammals. For coastal communities, it can feel like the sea is suddenly sick. The smell changes. The color changes. Dead fish wash ashore. And for the underwater world, blooms can be both a symptom and a weapon of imbalance. Number 7. Jellyfish blooms, an ecosystem warning light. Now let's talk about a creature that seems almost immortal. Jellyfish. Jellyfish are ancient. They existed long before dinosaurs. They thrive in conditions that stress many other animals. They can tolerate lower oxygen. They can survive in warmer waters. They can multiply fast. In some coastal regions, as fish populations decline and ecosystems destabilize, jellyfish blooms increase. A bloom can clog fishing nets. It can sting swimmers. It can overwhelm local ecosystems. It's as if the ocean, under stress, starts reverting to simpler life forms that can survive chaos. When jellyfish take over, it can be a sign that the ocean is shifting into a less diverse, less stable state. Number 8. Plastic pollution, the endless snowstorm. Now we face a problem that has reached even the deepest trenches. Plastic. Plastic doesn't disappear. It breaks into smaller pieces. Microplastics. Tiny fragments that drift through currents, settle into sediments, and get eaten by creatures that mistake them for food. Fish eat it. Seabirds eat it. Turtles eat it. Whales can ingest it. And as plastic becomes smaller, it becomes harder to remove. Even when plastic doesn't kill outright, it can damage digestion, reduce nutrition, and carry chemicals. It is like a permanent snowstorm of synthetic debris falling through the ocean, the kind of snow that never melts. And here's the most unsettling part. The ocean has become a storage system for humanity's waste, but it was never designed for that job. Number 9. Ghost gear, fishing nets that keep hunting forever. There's a specific kind of plastic pollution that is especially deadly: abandoned or lost fishing gear. Nets, lines, traps, sometimes called ghost gear, continue to catch animals long after fishermen have lost control of them. A drifting net can entangle fish, turtles, dolphins, and seals. It becomes a moving trap, hunting without hunger, killing without purpose. In a way, ghost gear is one of the darkest symbols of modern environmental damage. A weapon left behind, still doing harm. Number 10. The chemical soup, oil, toxins, and invisible pollutants. When people think of ocean pollution, they often imagine oil spills. Oil spills are dramatic and devastating, but the ocean also suffers from quieter chemical pollution. Industrial chemicals, pesticides, heavy metals, and other contaminants can enter waterways and accumulate in marine food chains. Some substances can persist for long periods and build up in tissues, especially in top predators. This is why some seafood advisories exist, because contamination can climb the food pyramid. It's not always visible. It's not always immediate. But it changes what healthy ocean means. Number 11. Ocean acidification, chemistry shifting in real time. Now we reach another silent crisis. As carbon dioxide in the atmosphere increases, the ocean absorbs some of it. When CO2 dissolves in seawater, it forms carbonic acid, altering the ocean's chemistry and making it more acidic. This is not movie acid. It won't burn your hand. But it affects organisms that build shells and skeletons using calcium carbonate, like corals, oysters, clams, and certain plankton. If shell building becomes harder, it can weaken the foundation of some marine ecosystems. And when the foundation weakens, everything above it becomes unstable. Number 12. Kelp forests, underwater jungles in danger. If coral reefs are underwater cities, kelp forests are underwater jungles. They support fish, protect coastlines, and create habitat for countless species. But kelp can be sensitive to warming and to disruptions in predator-prey balance. In some regions, when predators of sea urchins decline, urchins explode in number and graze kelp down to barren rock. A kelp forest can transform into an urchin barren, a landscape of emptiness where life becomes less abundant. It's another example of how the ocean can flip from rich to poor, sometimes rapidly, when balance breaks. Number 13. Overfishing, the quiet removal of ocean life. Now let's talk about one of the most direct ways humans change the ocean: fishing. Fishing is not inherently evil. Millions depend on it for food and income. But overfishing occurs when we take more than ecosystems can replace. What happens when we remove too many fish? First, populations decline. Then predators lose prey. Then ecosystems change structure. And sometimes, the system doesn't bounce back easily, because the web of relationships has been altered. Some fishing practices also cause bycatch, non-target animals caught and often killed unintentionally, including turtles, dolphins, seabirds, and sharks. And then there's the method that many consider among the most destructive. Number 14. Bottom trawling, bulldozing the seafloor. Bottom trawling involves dragging heavy nets across the ocean floor to catch species like shrimp or certain fish. Picture a giant net with weights and doors, scraping across seafloor habitats. It can flatten structures, disturb sediments, destroy coral gardens and sponge fields, and turn complex habitats into simplified wastelands. Some seafloor communities grow extremely slowly. Damage can last decades or longer. The deep ocean is not a barren desert. In many regions, it contains ecosystems that are as intricate as forests, except we bulldoze them in darkness, out of sight. Number 15, sharks and the collapse of top predators. Sharks are not monsters. They are essential predators that help maintain balance in marine ecosystems. When top predators decline, mid-level predators can explode in number, which can then reduce herbivores, which can then allow algae to overgrow reefs. This is called a trophic cascade. It's like pulling the top block in a tower and watching the structure wobble. The ocean's stability depends on food webs remaining intact. When we remove key predators, the ocean doesn't just lose animals. It loses balance. Number 16, climate change turns up the ocean's violence. Warming oceans don't only harm ecosystems. They also influence weather and storms. Tropical cyclones and hurricanes draw energy from warm water. Warmer water can strengthen storms and increase rainfall intensity. At the same time, sea level rise makes storm surges more damaging. Even if a storm is the same strength as decades ago, higher sea levels can push water farther inland. When the ocean warms and expands and ice melts, coastal life becomes riskier. The ocean is no longer just a beauty. It becomes a threat, because the forces it controls become sharper. Number 17, sea level rise, the slow invasion. Sea level rise is not just about water rising. It's about a new baseline that changes everything: flood frequency, erosion, saltwater intrusion into freshwater supplies, and displacement of coastal communities. It also threatens ecosystems like mangroves and salt marshes, which require specific conditions to survive. And as natural coastal buffers degrade, storms hit harder. Number 18, mangroves, seagrasses, and blue carbon. Not all ocean stories are doom. Some are hope and solutions. Coastal ecosystems like mangrove forests, seagrass meadows, and salt marshes store large amounts of carbon. They also protect coastlines and provide nursery habitat for fish. When we destroy them, we lose protection and release stored carbon. When we restore them, we strengthen resilience. It's one of the rare cases where environmental protection is also climate action and disaster prevention at the same time. Number 19, the deep sea, Earth's last wilderness. Now we descend again into the abyss. The deep ocean is vast beyond imagination. It contains mountains, trenches, hydrothermal vents, cold seeps, and ecosystems that survive without sunlight. Some life down there feeds on chemicals, not photosynthesis. At hydrothermal vents, the Earth's interior literally fuels biology. It is one of the strangest truths of nature: you can have an ecosystem powered by geology. And yet, this wilderness is increasingly on humanity's radar, not for discovery, but for extraction. Number 20, deep sea mining, the next frontier, or the next mistake. Deep sea mining aims at metal-rich nodules or crusts on the seabed. The promise is minerals for modern technology. But the danger is that mining could destroy habitats that might take centuries to recover, if they recover at all. Mining can create sediment plumes that drift across the seafloor like underwater dust storms. It can disrupt animals that filter feed. It can introduce noise and light. It can damage unknown species. And here's the haunting part. We do not even know what all is living there. We might be bulldozing a library before we read the books. Number 21. Ocean noise, an invisible form of pollution. The ocean is a world of sound. Many marine animals use sound to communicate, navigate, and find food. But modern oceans are noisy. Shipping engines, sonar, construction, drilling, all add sound. Noise can stress animals, disrupt migration, and interfere with communication. In extreme cases, certain sonar use has been linked to unusual whale behavior and strandings in sensitive contexts. Even if noise doesn't kill directly, it can change behavior, and changing behavior can affect survival. Number 22. Light pollution, bringing daylight into the deep. We rarely think about light pollution underwater, but artificial light can affect marine species, especially near coasts. Many animals use darkness as a signal, when to feed, when to hide, when to spawn. Bright coastal lights can confuse turtles, disrupt fish behavior, and change predator-prey interactions. In the deep sea, where darkness is permanent, light can be a shock to organisms evolved for blackness. As humans expand activities at sea, even darkness becomes disturbed. Number 23. The mysterious ocean, sounds from the deep. Now, let's explore the area where your channel shines, mysterious but factual. The ocean has produced eerie recorded sounds over the years, booms, groans, pulses, that captured public imagination. Some were later linked to ice movement, some to earthquakes, some to unknown combinations of natural processes. The point is not to claim monsters. The point is this: the ocean is so vast and complex that it produces signals we do not immediately understand. And as the climate changes, the ocean's soundscape changes too: more ice cracking, more storm turbulence, more shifting currents. It's like the ocean is speaking in a new dialect. Number 24. Strange deep-sea creatures, Earth's true aliens. Deep-sea creatures can look unreal. Transparent bodies, bioluminescent patterns, teeth like needles, eyes adapted to tiny traces of light, or no eyes at all. They live under pressure that could crush a submarine window. They survive on scarce food falling from above, sometimes called marine snow, the constant drift of organic particles from the surface. Some of these creatures reproduce slowly and live long lives. That means they are vulnerable to disruption. When you damage deep ecosystems, you are not just killing individuals. You are cutting a lineage that took geological time to evolve. Number 25. The shipwreck world, history under pressure. The ocean is also a museum. Shipwrecks preserve trade routes, wars, migrations, and human tragedy. They hold artifacts sealed away by salt and depth. But oceans are changing. Stronger storms can break wreck sites. Shifting chemistry can accelerate decay in some regions. Human looting can erase history. Even the ocean's memory is not safe. Number 26. Ocean currents, Earth's hidden engine. Now we reach a system so powerful it shapes continents' climate: ocean circulation. Currents move heat from the tropics toward the poles and return cold water at depth. They influence weather patterns and rainfall distribution. If major currents weaken or shift, the consequences can ripple across the world, changing rainfall, altering storm tracks, affecting agriculture, influencing sea levels along coastlines. This is why current systems matter even if you live far inland. The ocean is connected to wind, and wind is connected to rain, and rain is connected to food. We live on land, but we live under the ocean's influence. Number 27. When the ocean becomes unstable, cooperation becomes harder. Here's a difficult truth. As fisheries decline, competition can rise. As coastal flooding grows, migration pressure rises. As storms intensify, economic stress rises. Environmental change can become political stress. The ocean crisis is not only an ecological story. It is a human stability story. When the ocean shifts, borders, both physical and social, can get tested. Number 28. Can the ocean recover? This is the question that decides whether this story ends in tragedy or transformation. Some things can recover quickly if pressure is reduced. Fish populations can rebound if fishing is managed carefully. Coastal ecosystems can regrow with restoration. Plastic inputs can be reduced through policy, design, and waste systems. Nutrient pollution can be reduced through better agriculture and treatment infrastructure. But warming and acidification are tied to emissions. That means the biggest leverage is global, reducing greenhouse gas emissions. Marine protected areas can help ecosystems rebuild resilience. Sustainable seafood choices can help reduce pressure on vulnerable species. Enforcement against illegal fishing can protect stocks. Technology like satellite tracking can identify suspicious fishing patterns. Scientific tools like environmental DNA can help monitor biodiversity with less invasive sampling. The ocean is resilient, but only if we stop punching it while asking it to heal. Number 29. What you can do without being powerless. Many people feel helpless about ocean problems because the ocean is huge and the crisis feels global. But action is not always about one person saving everything. It's about reducing pressure and supporting systems that protect the ocean. You can reduce plastic use, especially single-use plastics. You can support policies and leaders who take environmental protection seriously. You can choose seafood from sustainable sources when possible. You can share educational content so awareness spreads. You can support organizations that clean coastlines or restore mangroves. And even if you do none of these, there is one action almost everyone can do. Pay attention. Because attention is the beginning of change. The worst disasters are the ones nobody notices until it's too late. Number 30, the final mystery: what happens if the ocean tips? Here's the haunting question. Systems can absorb stress for a long time, and then suddenly flip. This is called a tipping point. It can happen when reefs collapse into algae-dominated systems. When kelp forests become urchin barrens. When oxygen loss changes what can live in a region. When currents weaken enough to reshape climate patterns. We do not always know exactly where tipping points are until we cross them. And the ocean is full of thresholds we barely understand. The ocean is not just changing. In some places, it is transforming. Closing, the collapse is silent, until it isn't. The deep ocean is Earth's greatest mystery. But the crisis unfolding there is no longer a mystery. Warming waters. Bleaching reefs. Oxygen loss. Acidifying chemistry. Plastic snowstorms. Ghost nets. Overfishing. Seafloor destruction. Deep sea mining pressure. Currents under strain. A soundscape and ecosystem being rewritten. And it's all connected. The ocean has protected life on Earth for a long time. It has buffered heat. It has fed us. It has regulated climate. It has hidden wonders in darkness. But it cannot carry the weight forever. If this video opened your eyes, please like it, share it, and subscribe to Uncovering Facts, because the most important stories are often the ones happening where nobody is looking. And now I want to ask you something. Have you ever witnessed something unusual at the sea? Strange tides, unexpected fish, unusual jellyfish blooms, dead fish after a heat wave, or a coastline changing faster than you remember? Tell your story in the comments, and let's compare notes, because sometimes the ocean sends signals, and we only understand them when we share what we've seen.